So apologize for the delay. iClicker should be on in a second. Where is iClicker? Start class. Okay, so any questions about the exam? First, the exam will not be on Friday. It will be on Monday. And then Friday, I will continue the lecture. It will not, the material on Friday will be on exam 2, but not exam 1. Okay. Any question? If there is no question, then I can start covering the materials. You guys are really nice this year. No complaint yet. I'm very surprised. Okay. Yeah, we can. Which one that you want to cover? So, all right, let's do this problem. Is that good? Yeah. What is it about? Sorry, 8th. So let me count. 1, 2, 3, 4, 5, 6, 7, 8. Is this the problem? First, there are missing options. And for this, you can work with your neighbors. Okay, so the problem says it should appears on the right screen. Which of the following graphs represents the magnitude of the electric field as a function of the distance from a center of a solid, I guess, sphere or charge conducting sphere. Okay, charge conducting sphere of radius r. So you know this from SEN that when you do a physics problem, it's better to start writing and drawing. Okay, so this is a conducting sphere. Okay, the radius is r. Right. So what do we know about sphere, about conductors? That the electric field inside is equal to 0. Right? I see. Actually, I gave the answer of this problem in the answer key is actually wrong. Sorry, I gave that to 5 of you or 10 of you. Because those guys have finished the study guide. Okay? So if you have finished the study guide, you can email me and I'll give you the answer sheet. I thought that the question asked about voltage, not the electric field. So again, this is a lesson for me and also for you. When you do problem set, you should read the question carefully. Okay, so if we plot the electric field, right, R0 is the center of the sphere. We know that the electric field inside is equal to 0. Good. So let me use red, 0. And then outside should follow what? Coulomb's law and Gauss's law. So it should follow like this, which is E is proportional to 1 over distance square. And then it should approach to 0 at infinity. So the answer is B. Okay. 30 30 of you need to log in the answer. So that's basically 3 points. Okay. Any other question? Is that clear or no? How about the voltage? So for the voltage, so this is again R. What is the voltage inside a conductor? Does it depend on R or changes or 0? Who thinks that the voltage inside the conductor is 0? Nobody. It can be. What is important is that it stays the same. If there is no charge on the conductor, then the voltage is 0. If there is charge here, right? If there is no charge, then the voltage in the conductor is 0. So we know that outside conductor, it follows 1/R. This is voltage or potential or electric potential. And inside conductor, it stays constant. Because delta V divided by delta R is equal to 0. So E along 1D in this class, X is just a parameter, right? All of us are human. Your name is, forget, Holden. Your name starts with N, maybe, Nathan. Okay, so I used to be really good with students' names. I guess I'm old right now. Okay. So since E is equal to 0, then V, the change of potential along, okay. The reason why I'm asking your name, X is just parameter. You can write Y, you can write Z, or you can write R. It's fine. Right. So the change of E along R, which is along the radial direction of a conducting sphere, is 0. That means the potential is constant. You can write, I don't know, V surface or V naught, or you can define what that number is. Okay, good. And for those of you who has the answer key, I think I made a mistake. For sure, I made a mistake when I wrote the answer key. I thought that it was potential. So, how many of you have finished the study guide? So I'm going to be nice to you. I'm going to post the answer on when? Let's say Friday afternoon. Okay? The idea is I want you to try it without knowing the answer. Try it yourself. Because the answer key will be right next to the question. So it's really, at least for me, it's difficult to not see the answer after I spend a long time working on a problem. But I want you to struggle with it a little bit before the exam. And then during the exam, you can solve those problems really fast. The answer is B. Any other question? Let's do, so far what we have done for capacitor is a simple example. Let's do more difficult example. Is that good? I'm gonna mute computer a little bit because I'm gonna open last year's exam. And I'm gonna choose the most difficult question for that exam. The idea is so for you to get some sense of the level of difficulty. Second. Meanwhile, if you have any question, you can ask me right now. So the rule is, there is one more thing that I forget to mention, which is after you submit your answer, I want you to take a picture of your scratch pad and upload it. This is for you. So if somebody accuses you for anything, you have the proof. And sometimes if you made a mistake clicking the options, you can negotiate with me. See, I answered this thing right, but I clicked the answer wrong. So it's for you, really. And you have until 1 p.m. to upload your scratchpad. So, and then I'm gonna send this. Okay. So I send a question to your iClicker. Ah, so actually, so I mute the wrong screen. Sorry. So you have seen the old exam then. Okay, interesting. So this is what I consider one of the most difficult questions in last year's exam. Okay, and I haven't solved this problem before the class because we are hosting a speaker from University of Minnesota. His talk will be at noon today. So the question is, there are three capacitors. They are arranged as shown in the figure here. So let me draw it not too high. So this is one capacitor. Again, capacitor in this class, you can think of it as a parallel plate that are charged. If you read different textbook, in the old days, some of them draw the symbol of capacitor like what we see in this class, or sometimes there is a curve. Yeah, this is also a capacitor. The reason is because some capacitors, they have polarity. And from your perusal, you know the unit of capacitors. Anyone still remember? What is the unit of capacitors? Barrett, yeah. So can C is equal to Q, or Q equal to C times V. C is equal to Q divided by V. So coulomb per volt or farad. Thermal unit is, or F. And F is very big. So typical capacitors are picofarad, microfarad, not farad. Okay, so the capacitor is a combination of series and parallel. Okay, so parallel and series. So C1 is 20 picofarad. C2 16, C3 24. Okay. And then what is the next information? Find the voltage drop across the entire arrangement if the voltage drop across C2 is 50 volt. So the voltage drop across C2, let's say delta V2 is 50 volts. Okay, do you want to try this? So probably the most difficult questions on the exam is either easier than this or more difficult than this, of course. that's the biggest leak of the semester. Meaning like it's not going to be way more difficult than this. It's not going to be way easier than this. that's what I'm trying to say, because it's subjective, right? It's difficult to come up with exactly the same level of difficulty. Do you want to try this? Why don't you try this with your neighbor? And then for 2 minutes, and then enter your answer, because I need to try it also by myself. All right, so you can work with your neighbors. You need some hints? All right, so hints. Red is in hints. Well, red is the color of blood, so green is the hints. Your exam, everything will be red on Monday because of the color of blood. All right, so the hints. So what is delta V? Delta V is the change of voltage across C2. What is the voltage drop across C3? Good. Who said the same? Congratulations. So it's same. Okay. Okay. Huh? Oh, because they're connected by wires. So if you have a conductor, the voltage is the same. Remember here? The voltage is the same. So wires are conductor. I mean, if somebody sell you wires that is insulator, then you're not my students. So delta V, 50 volt. This is also 50 volts. And then the question is, what is the voltage drop across the whole thing? You can, so if you want a parameter, what is delta V? So this is delta V1, sorry. So what you're asked is V, delta V total, which is, okay. So that's one hint. Another hint is in capacitor, we can store electric potential by storing charge. So we have minus Q here and minus Q there. Here, so Q is the charge on the capacitor, but they have to be equal because you cannot create charge nor destroy them. Here you can, okay. Here is not the same. So this is not plus Q. This is not plus Q here. Because if you do that, then there is no, you cannot, then in this part of the conductor, you get minus plus plus. So this one, the sum of Q3 and Q2 has to be equal to Q. So how would you do that? You can collapse C3 and C2 into one. So you first need to find the equivalent capacitor for C2 and C3. Does it make sense? So you can transform the circuit. I need to be careful because when I post on YouTube, this thing will be covered. So you can change the circuit into like this. Right? So this is C1, this is C2, 3, or C equivalent. Okay. So this is 20 picofarad. And what is the combined or equivalent capacitor for a parallel capacitor? The sum. 16 plus 24 is so 40 picofarad. Okay. So we can, I don't recommend doing this, but because of the space, I'm gonna redraw the circuit to be like this. So right now C23 is equal to 40 picofarad. Okay. Now it's a circuit in series, so you have plus Q here and minus Q here. Okay. Is it clear? And what is next? So we know the voltage drop, which is 50 volts. So you can find Q. And if you know Q, you can find the voltage drop across C1. And then if you sum delta V1 plus delta V2, you get the answer. Oh, actually, I give the equation here. Do you need help? Yeah, Sophia. Oh, here, 50 is here. This is not wire. Something. Oh, and I need to be careful with the unit. Good. Okay. So what is Q here? Okay, I'm not gonna continue until somebody answer the. Meaning, like, what is the formula? You don't need to give me numbers. So Q is defined as C times V. I know I put delta, but you can remove delta. And this one, for capacitors in series, then this one is equal to C to 3 times V, basically this, and also equal to, I'm really sorry, I'm trying to help you by removing the delta. So all the formula is consistent. Okay. C2 3 times V2 and C1 times V1. Because Q for C1 and for the formerly capacitors in parallel is the same. Q, Q. And they have to be equal, because otherwise you get non-zero charge. Because you have plus Q here, then you need to have minus Q here. And also, since you have minus Q here, you need to have plus Q here. So what is Q? Excellent. So Q is 200 or 2000. 200 and 02. And then you're better than me in terms of unit. Let's just do this. And you know C1. Okay. I'm gonna change color, not because I'm trying to send a message. And then V1 is equal to Q divided by C1. So 2000 picofarad times voltage divided by C1. What is C1? 20 picofarad. The unit cancel. 20 also cancel. You get 100 times volt. I know I said voltage. I should have said volt. So V1 is 100. Okay. So 100 plus 50 is equal to 150, which is C. Okay. You can type C if you want, or anything. That's the answer. So there are multiple steps. There is at least one problem with multiple steps. And if I don't give steps in between, because the philosophy or the goal of those problems is to see whether you can come up with a solution that involves multiple steps by yourself. It's not because I forget to break the problems into multiple steps. I obsess with the exam. Every decision actually has a goal. Yeah. Yeah. So this is like, so let me repeat the question. If parallel, whether the voltage drop is the same, we can use the analogy. So this is the gravitational energy analog of the problems. So we have two capacitors. I know initially we had three, but after we collapse the capacitors in parallel to be one, so we have these two drops. So in this case, first 100 and then 50. 100 and then 50. So voltage is the gravitational analog of electric potential. And then for your question, apologize, I don't remember your name, but I'm learning my best. So this is parallel. So the voltage drop for initially C2 and C3, they're the same. So the height difference is the same. Okay? Any questions? Yeah, what's your name? I need to listen your name, yeah? Huh? Okay. I see. So positive and negatives, it depends, right? Meaning like there are many, can you please be more specific? The work, okay. So the context is the work instead of charges or electric energy, electrostatic energy. So I guess some of you may say my hobby is making analogy between gravitational forces and Coulombic interactions. So let's use gravity as a framework, or and then we can see whether that thing helps or not. So let's say I drop this. Yeah, I drop this thing, right? I drop this sprayer. Then the sprayer goes down, and in physics, this is how we draw anything. So spherical spray goes down because there is a gravitational force, right? So the work done by the gravity is aligned with the displacement. So the work done by the gravity is positive. Okay. And then there is another case where I actually lift the spray. So from this height to this height, there is a much larger force, F, I don't know, 112. Then in this case, in the second case, the gravity still does work, but it's the opposite of the displacement. So the work is negative. The work done by the gravity is negative. The work done by me is positive. So that's in the context of work. Okay. Yeah. It also has something to do with how we decide the coordinates. So like negative electric potential, that means it takes work to separate the charges. So if we have positive and negative, if you let these charges go, they will go towards each other. So the energy is negative because for us, what we care is how we separate the charges. This is because when we set up a coordinate system, if this is your positive charge, this is XYZ. I'm not sure whether this helps. R is away from the source of the charge. Still have alcohol here. So R is away. So positive R points away from the source of the charge. This is our coordinate system. So if the energy of two positive charges separated by distance r1, 2, let's say, it's positive, because if we let these two charges go, this charge will move towards the same direction as our coordinate systems. But basically, in terms of like daily language, it takes energy to separate two charges. That's basically it. Yeah. Electric potential, the way we use electric potential is the same way as we think about height. Like this spray will always go from high elevation, high H to low H. Electric potential, if you put test charge, it will move from high potential to low potential. So if you put battery has let's say plus 1.5 volt, it goes from high voltage to zero. That's how we use electric potential. So there will, as of now, there will be questions that involve capacitors in series and parallel combined. So you need to be confident. You need to practice for that. I had one question about this iClicker question. So let's spend, the reason why I'm choosing this because it somewhat relates to your question, not about the sign, but about potential energy. What is potential energy? And I give you a minute. And you can work with your neighbors. You need more time, so only 100 of you have logged your answers. So 30 more seconds. So it has electric potential, charge. The question is, what is the kinetic energy? It's a good question. All right, 10 more seconds. 5, 4, 3, 2, 1. Excellent. Okay, so what is potential energy? Potential energy is an energy that we can use for other things, typically mechanical. So let's say in Tesla, I love using Tesla because my wife doesn't allow me to buy Tesla. In Tesla, we store the energy in battery, and then the machinery convert that energy to mechanical energy, right? Convert potential energy to mechanical energy. It doesn't have to be mechanical energy. It could manifest in heat, sound, or other energy form. Okay. So in this case, we have a constant potential difference, not constant potential. There is delta V from one point to another point. Delta V is equal to 1 volt. Yeah, 1 volt. And then there is an electron or proton. Wait, what? What? Proton, yeah. So basically plus Q. And then Q is 1 proton is 1.6 times 10 to the minus 16, I believe. 19 coulomb. Okay. So basically here, the proton will convert potential energy. I think your book used the symbol U to kinetic energy. So the potential energy is basically just Q times V. What is Q? Q is 1.6 times 10 to the minus 19 coulomb, and V is 1. So the answer is A. Okay. So from time to time, I give you more information that you need, not because I like to be tricky, but it's actually to test your understanding. And there are times that I use different units, most likely because it was a mistake. I don't like testing the unit, but unit is part of life, right? So you need to get used to different units, whether you like it or not. I grew up in metric system. I live in the US. I use imperial. I don't like it, but I have to survive. Any other question? You have a question? Yes, you. Yeah. Yeah, you. Yeah. Okay, good. How about you? Okay, let me do the same exercise again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is this good? So, this some of you asked me about this question. Maybe you send me an email. Electric field is uniform with a magnitude E. So let's draw that. It's uniform. E. Uniform. The area of one side of the, okay. So I'm gonna assign this as an iClicker question. The area of one side of the cubical surface is A. At this point, we do not know whether there is a charge enclosed by the cube or not. What is the total flux going through the cubical surface? So let's draw the cubical surface in 3D. Or if you want to draw it in 2D, the cross section, let's just do 3D. So one thing that probably I didn't emphasize during the lectures is that the flux can be positive or negative. Positive flux means the electric fields pass through or like travel, like pass the surface away from the source. Negative is the electric field points toward the surface. So in this case, the flux on the top, bottom, and side, they are equal to 0 because they are perpendicular. When I say perpendicular, it's perpendicular from the line that is perpendicular from the surface, or we call that a normal vector. So there are only two areas with non-zero non-zero flux, which is this area and this area. Let me just write area 1 and area 2. And flux is, the formula for the electric flux is E times A. And E is constant. E is uniform. It doesn't depend on location. On surface 1, E goes into the cube. On surface 2, E goes away from the cube. Is that clear? Goes into the cube, goes away from the cube. You can use cosine for, the normal vector here points like this. The normal vector of area 1 points the opposite direction. So you can use cosine theta to be either minus 180 or 0, or you can use physical intuition, which is one goes away from the normal vector or goes into cube. The other one goes out of the cube. So basically this one goes into cube, is you can set that thing to be negative. So this is from area 1, and then plus this one is away from the cube, so E times A. So what is the answer? The answer is 0. So this problem is kind of tricky because I said that at this point we do not know whether there is a charge enclosed by the cube or not. Okay. But yeah, so but we actually have enough information to solve the problem. So I don't accept E. The answer is C. And I forget to assign this to iClicker. But I want to touch 2 more questions. Because one student asked me, like emailed me about this question. Okay, so this is one of them. Let's do parallel, or maybe series. 3 identical capacitors are connected in series across a potential source, which is basically a voltage. If a charge Q flows into this combination of capacitors, how much charge does each capacitor carry? So it is a series. So the arrangement is capacitors in series. So what is the answer to this? Unfortunately, I erased the drawing before. So capacitor in series, it doesn't have to be, they don't have to be equal capacitance. So if there is charge minus Q and plus Q on one capacitor, what is the charge of the other capacitor? Plus Q minus Q. So the answer is B, because it's in series. How about the other one? So this is the last one, and let me assign this as an iClicker problem. Right now, we have 3 capacitors in parallel. And they're identical. And initially, so basically the total charge is plus Q and minus Q. The question is, what is the charge that each capacitor carry? Okay. Remember, the question is not about the equivalent capacitor, but the question is asking you about Q, about the charge. Okay. 3 more seconds. So essentially, all of you have answered. Good. So the right answer is C. Yeah. So this one, maybe we can chat after the class. Is that good? I'll be in that room. We call it Student Success Center. Any question about Friday or Sunday? Oh, sorry, Monday. No, I'll see you on Friday, and I will be in that Student Success Center. Yeah.